going to do the writing and then the solving. So basically all we're doing is just trying to figure out a variable and solving for it. So sometimes you'll plug something in, sometimes you might have to solve a quadratic, all stuff we've been doing. This is, I don't know where this came from. This was like magically appeared for me. I don't know why there's like random fish here. You can't really see the title, so it's quadratic.
Yeah, only fish on one side.
I know, quadratic application word problems, algebra. I was like trying to edit it and I got so annoyed. I was like, the fish are staying and you just can't see the title, but whatever. Things to remember when completing quadratic application word problems. So T is the time. So you guys in front of me is like that first blank little thing. It represents the X variable. So I'll show you it represents X. Okay, so T is time. In our case, it would represent something on the X-axis. H, or D, depending on the problem, is height. So H is height, D is distance. It's kind of the same idea. A lot of times you talk about a ball being tossed or a rocket or a rock being thrown, so same kind of thing. And that represents the Y. The height. That kind of makes sense. Why? How high something is. Okay. So just general ideas going into it. Really, all we're going to do is read and be like, okay, what do we do with this equation? That's really as crazy as we're going to get today, which is exciting. So nothing too nutty. Sorry, let's actually see where I am at home. Okay. So you guys should be able to see this 1A. So one I read through. After T seconds, sorry, once again, T is time. A ball is tossed in the air from the ground level. It reaches a height of h feet given the equation. Okay, so that's a lot of info. I really care about the equation. So the equation is h equals, this isn't really, no, equals 144t minus 16t squared. Good stuff. What is the height of the ball after 3 seconds? Hey guys, what should I do with the 3? Plug it in for T.
Hi.
Hi.
Would you like a projector?
I would love a projector. He can move, so he's not like awkwardly above you. Or you could just move your like entire.
Oh, that would have been smarter.
Yeah. Whatever works. I just didn't want you. Guys, I'm gonna. My projector is a hot mess lately, so I'm so excited right now. Happy Friday to me. Okay, anyways, yeah, you just kind of think like, what is 3 seconds? It's the time. So if T equals 3, we're literally just gonna go back here and plug it in. I always like those ones, they're kind of easy. So you just throw it in, H equals 144 times 3 minus 16 times 3 squared, and that will give us H. So can everyone try to find that now? I'm gonna grab my calculator as well. I have no clue what the answer is, I'm going to be honest. Okay. 3 minus 16 times 3 squared. I got 288. Did everyone else get that? Okay, 288. There's going to label it 288 feet. So A is done. Okay, that was kind of nice. So once again, we're not killing ourselves with like. B, we're going to come back to in a minute. Well, we'll see. I was going to project something, but we'll see. So B we'll come back to. Just leave it blank for now. It has to do with the graph, and I was going to show you the graph, but we'll see in a few. If not, I can show it to you next week. And we're going to do graphing next week anyways, so we can relate it to there. See. Find the number of seconds the ball is in the air when it reaches a height of 224. So hopefully it makes sense. We're going to plug in H is 224. And we'll go back to the original equation and plug it in. So I'm going to throw that in. So this one has a little bit more work because you don't just plug it in and you're done. Once you plug it in, now we have a quadratic equation we have to solve. So that's kind of the difference. But it really is just about what do you have, plug it in, and kind of see what you can do from there. So I'm going to make this, I'm just gonna put it in standard form and use quadratic formula because I know it's gonna work. It might be factorable, I don't really feel like factoring it, so I'm gonna move everything over here. I like to make that t squared positive. So standard form equal to 0. Once again, I'm just choosing quadratic formula. The numbers are a little bigger. I just don't really feel like trying another method. If you do, go for it. So I'm gonna start to plug in. So t is gonna equal, not x this time, 144 plus or minus, ooh, word from yesterday, I'm gonna find the discriminant. So I'm gonna throw that in my calculator. I got 6,400, so just make sure we're getting the same thing here, over 32. So I'll give you a second, just so I'm not rushing. Hey, that's a perfect square. So I kind of figured 64 and then 100. So since it's a perfect square, technically we could have factored it, but once again, I just didn't really want to. And now we know that there's going to be 2 real rational answers. So let's find them. So 144 plus or minus, the square root of 6,400 is 80 over 32. And then I am going to split that up to actually find my 2 rational answers. So, excuse me, I said 80, but I wrote 8. Okay, there we go. So I'm going to add ones and subtract ones to get those 2 answers. So literally the only new step from today was taking the equation and know where to plug that number in, and then hopefully it's all reviewed from there. So let's find those 2 answers. Um, 2 and 7, that's what I got. Okay. So I got t equals 2 and t equals 7. So once again, we'll talk about what that means like graph-wise in a few minutes. I just want to do D, just get it out of the way. And I'm just working in like a weird, I don't even know what I'm doing. So I'm going to erase everything in a moment, but I'll give everyone a second in case you're still writing. Any questions before we move on to D? Anyone at home? I'm so excited. I'll give you about, I don't know, 15, 20 more seconds. If you need anything, write it down. If not, I'm going to erase just because I have limited room with the camera and I'm all jumbled right now. Anyone still need it? Anyone at home? Okay, I'm going to erase. Okay. Just out of curiosity, did any of you have graphing calculators here? 1. Anyone at home have graphing calculators? Oh, you guys can hit the little raise your hand button if you have a calculator. Or a graphing calculator. Ooh, 1. Anyone else? Oh, a few, okay. I do want to start showing you things on the graphing calculator. We don't need it this year, so you'll be fine without it. But once you get to pre-calc, it will be pretty necessary to have. Or if you end up taking stats, you'll need it. You definitely, you can't even do stats without it. Calc, definite. So I'll start to kind of show you things. One of them will be how to graph on it. But if you don't have one, it's not a big deal. But if you have it, you might as well know how to use it. All right, let's do that last D. And then we'll kind of backtrack. After how many seconds will the ball hit the ground before rebound? It tells us right at the top, so if you have it in front of you, great. When an object hits the ground or water, depending on what you're talking about, its height is 0, right? And whenever we're talking about height, we're talking about height off the ground. So if you're hitting the ground, your height is 0. So that means my h is 0. So I'm just going to replace that in my equation. 0 is going to equal 144 t minus 16 t squared. You can choose a few different ways to solve this one. You're more than welcome to use quadratic formula, where just be careful because things are out of order. Where you have your quadratic term, your linear term, your constant would be 0. You could actually use that. I don't know if that's factorable. Maybe you can take out a GCF for sure, and then you could do square roots. So why doesn't everyone solve it how you want it? I'm going to solve it my way, and then we'll check to see if we're getting the same answer. So I just need things in standard form. I have to rearrange this. This is driving me nuts. Now that I did that. So I'm going to use square roots, but I have to take a GCF out first. No. Actually, I'm not using square roots at all. I'm just doing the GCF and then I'm solving. Because when I take that t out, I'm just left with t minus 9. Oh, that's way easier. So as you're finishing up solving, or as your mind is up on the board, so you can kind of check yours, we should get the same answer no matter what method you chose. So if you just threw it in the quadratic formula, that's fine with your C being 0. Once again, my brain can't process. So I put it in standard form, and then once I started in standard form, I said, hey, they definitely have stuff in common. So I took out that GCF, or you could just do 16t. You didn't have to change the sign, but same idea. And once I took the GCF out, I was like, oh, I don't even have to do anything to that. Now I can just set both of these equal to 0. And I got my two answers, of which were 0 and 9. So I'm going to do a quick visual. It's not going to be great because I'll do it later for you on the graphing calculator. So here's what happens. What are we talking about? Mr. Hayes is getting aggressive with this. We're talking about a ball being tossed, blah, blah, blah. So here's what happens. The ball's here. I mean, it's somehow being tossed from ground level. I guess the person's down there. It goes like that, whatever. You toss it up. It comes back down. It hits the ground. And then it might bounce after that. But that's kind of what we're caring about. So we're saying the ball is on the ground at 0 seconds. So I'll put my things kind of right here. It's on the ground at 0 seconds. And then it hits the ground at 9 seconds. Okay?
Well,
Huh?
it was in the air for a really long time.
Yeah.
Can I turn it on? Or
Oh yeah, turn it on.
Yeah.
Sorry, yeah, that'll on.
it only took me a minute to set it up.
Set away. Do you use those old projectors for anything?
No.
I didn't think so, but do you want my?
I'll take the.
I have 2 clickers for some reason.
The one thing I would say, I've been telling everybody, is put the room number on the new remote.
Oh, good idea.
You know what I'm saying.
Oh, that's probably why I have 2 clickers until someone else. Sorry, so we're just gonna have random things up, but that's okay.
Oh, what did I do that for?
Sorry, I know you have a glare at home. Anyway, so it's in the air for 9 seconds. What else have we found? We had found that 2 and 7 seconds was when it hit 224 feet. Okay, this person is like, how high is 224 feet? That's ridiculously high. So anyways, this person is like bionic and they can go really high. So let's say that was 224 feet. they hit it at 2 seconds and 7 seconds, so once it gets to that 7. Okay, we're at home. Woo!
I know.
No, it's fine, you're fine. So here's my question, kind of backtracking. We had skipped B, and B said, what is the maximum height? So let's think about it, guys. We'll think this. If it was at the ground at 0, and it was at the ground at 9, and we have a nice parabola, right, which is a nice symmetric shape. When, at what time would it hit its maximum? Halfway in between, so at 4.5. So at 4.5 seconds, it's hitting the maximum point. Okay, can someone be fancy? If I say the maximum is at 4.5 seconds, what is the maximum height? Can someone tell me? It's just throwing it in your calculator.
So, this is gonna be the video. You won't use the black box to turn the video
My
on.
black box doesn't work.
Yeah, good. Then I'll,
So I don't use the black box for anything.
you're perfect.
Okay.
324.
That's it.
So it's just on, so that's about all, as crazy
That's
as
about all
it
you gotta do. The light
gets. Into that.
bar right here
Yeah,
is blocking everybody's. And we don't have an answer for that.
hey, whatever.
But
Better than my one. I'll take
I
it.
made it so that
Just
the window of the
It's like,
Chrome
yeah,
should be
in
visible.
that area.
Just the bar top.
Okay,
That's it.
that's fine. Thanks, I'm so excited. What a day, guys. I'm gonna remember them.
Very exciting.
Sorry, Moo, what was the maximum height?
324.
324. So if you kind of backtrack to B, now that we have like the idea of what was going on, the max height was at 324. Which is ridiculously high. Like, I don't know how anyone would ever toss a ball up to 324 feet, but you got the idea. No, that's huh? 324 feet? That's like, I can't even like visualize how tall that is, but it's ridiculous.
It's like throwing the ball from.
And you started from the ground, so you didn't have.
Yeah, you're down here, sorry. And you're just like that. Well, a football field is 300 feet, so you would toss it as high, even higher than a football field.
Maybe they fixed it.
Maybe. Well,
That's more realistic than throwing.
it's not the most
Kicking the
realistic
ball
problem.
300 feet is no. Unless if it's like a drop.
It's not the most realistic problem. You get the idea. What are you gonna do? Okay. So the main thing we saw was, all right, we start with an equation, so you don't have to write the equation. That kind of saves you from some annoyingness. The main goal is, okay, I'm given this value, where do I plug it in? And then once you plug it in, you're just trying to solve for the other variable. Sometimes you just kind of plug it in and you're done. Sometimes you might have to solve a quadratic, but we know how to do that. And that's that. So let's look at the next one. So there was only 3 problems, I think. Yeah. Number 2 is very similar to number 3. This one will be more realistic. It's about a rocket. Ooh, a rocket carrying fireworks. How exciting. Is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. Okay, that makes sense. The rocket's height above the surface of the lake is given by an equation. So we'll start with an equation. Making sure no one at home. Thank you for bearing with me while they were doing my projector. I was doing the math, like we've been in this school, like I feel like the school is new. We've been here for 14 years. So that projector was 14 years old. Plus, let's be honest, they probably got like the crappy ones. So it was actually like 16 years old. It was a struggle daily. So. All right, so we got this nice equation. What is the height of the rocket after 1.5 seconds? Once again, where am I plugging it in? I have time right now. So I'm plugging in T is 1.5 and I want to find the H. Okay, so I always like those ones. They're quick. Because you just kind of throw it in and then you use your calculator to give you an answer. So A is always my fave. So let's see what we got. Plus 64 times 1.5 plus 80 is 140. Okay, so after a second and a half, it's at 140 feet. Fabulous, okay, that one wasn't bad. For B, what is the maximum height? We'll do kind of the same thing. We'll backtrack once we have the idea of what it looks like. And maybe this one I can actually project on my new projector. And I'll show you some graphing stuff. So I'm gonna skip to C. How long will it take for the rocket to hit 128 feet? So I want H to be 128. So I just fill it in, replace it in my equation, and then solve. So I'm gonna have 128 equals negative 16t squared plus 64t plus 80. I'm looking at that, I'm saying, like, once again, you have a lot of options, but when I see bigger numbers, I just really don't feel like dealing with them. So I'm just gonna set this equal to 0. I'll get a quadratic equation in standard form equal to 0. So I'm just gonna use quadratic formula. I get lazy on word problems, especially when the numbers are bigger. I just don't feel like dealing with it, so I start to plug in. T equals negative 64 plus or minus. I'm just gonna find my discriminant right in my calculator. So we talked about that yesterday. Minus 4. And that gives me 1024 over negative 32. I believe 1024 is a perfect square. What a delight. So we are going to get 2 real rational answers. Okay, we're just going to get 2 regular old answers. So once I find the square root of 1024, which is 32, I'm going to just split up that equation to add ones and subtract ones. So I'm just going to do them right in my calc here. So if I add and then divide, my first answer is 1. If I subtract and then divide, my second answer is 3. Excuse me. So this isn't set up basically just like the other one we just did. After. Sorry, I have more room over here, so I'm going to do D over here. I'm in a weird space with my trying to fit everything. After how many seconds will it hit the lake? So in that case, the water, basically ground level, or we'll say sea level. So our height, we're going to say, is 0. So if you want to try a different method, go for it. There's definitely a GCF in there. It might be factorable. Let me check. Oh, I can check the discriminants, guys. So when I check the discriminants, it is factorable. I just don't want to do it, so I'm going to be honest. I know the quadratic formula is going to work. I get lazy. So T is going to equal negative 64 plus or minus my discriminant, which I just did right in my calculator. Comes out to 9216. That is a perfect square. The square root of 9216, who would have known, is 96. And then I'll just add ones and subtract ones to get my 2 answers. All right, and then there. So it looks very similar to the last one. A lot of these quadratic ones are kind of the same idea. You're throwing something, you're shooting something, I usually like throw my marker, we do it, whatever works. We have something that's gonna make a parabola, and good old gravity makes it come back down to Earth, so that's why the parabola happens. Hey, can someone tell me why I got an answer that was negative? Yep.
Because it started over the ground.
Yeah, it didn't start on the ground, it started up on a cliff. So when you think about it, the parabola, it started up here, up on the cliff. So that's kind of like going backwards in time. So the equation doesn't know that it started on the cliff. So we don't care about negative times. So it's only gonna hit the ground once, and that's when it, or hit the lake once, that's it. Oh, let's try my new projector, I'm so excited. Little things in life. So much more high tech. Ooh, it doesn't even make noise either. So I'm gonna go to Desmos right now. So they have a good graphing calculator. I'll do some stuff next week with the actual, like, if you have a graphing calculator, I'll show you some stuff. Just so you get to start getting into it. Okay, let's see. I'm just putting this down. There's not a massive glare for the people at home. Guys, I bought curtains yesterday for my room, so hopefully next week it'll be. Oh, this is already looking way better. What a delight. Hey, they're at a weird angle. Hold on. Sorry. There you go, the idea. I want them to be a little higher. Look up. All right, beautiful. So once again, Desmos is a free resource, so I suggest you use it if you don't have a graphing calculator. Our next unit is on graphing, and I like still to this day when I do answer keys, I always just check myself using them because why not? It's easy. So I'm gonna put in that equation. H equals, or I guess I don't know anything for H. Negative 16 t squared plus a 64 t plus 80. Actually, I probably need x and y here, so I'm gonna put x, and I'm gonna put y equals. Okay. So we have this. When you look at that, you're like, what the heck is happening? That's just two lines. It's just because it's zoomed in. So you can either do this minus sign, or you can kind of zoom out. You can also change the scale. So I'm gonna change my scale. The x, I'm gonna go from negative 10. What did we say? When did it hit the ground?
5 seconds.
What was the answer to D?
5.
Oh, 5, okay. Oh, look at how much beautiful, okay, that looks even better already, okay. So we can see right now, we said the x-intercept where it hit the ground was at -1 and 5. Once again, I didn't care about this. It makes sense that the y-intercept is at 80 because it told us originally. It went off a hill that was 80 feet above the lake. That's what that plus 80 represents. We see our nice cha-cha-cha. So this one, technically, you could find the midpoint between -1 and 5, which would be at 2, right? And then you could just go up. So I'm just gonna go up and look. You could plug it in if you wanted to, but you don't have to. So this is the answer for B. The maximum height after a time of 2 seconds is up at, that's why I really like this, because you can literally just point on that and it tells you, at the points 2,144. So after 2 seconds, it was at a height of 144, and that was the maximum height reached by the rocket. So we call that the vertex. We talk a lot more about that next week. But use your resources. So you guys have technology, and you're always on technology, so you might as well use it to your advantage. I'm not saying put everything in this, but if you're like ever like, I don't know if that's right, but just check yourself. Why not? You got it. You might as well use it. All right, so number 3, so this is our last one. A rock is thrown from the top of a tall building. Well, that's just not very safe, but okay. The distance between the rock and the ground, t seconds after it's thrown, so we're given some nice equation. How long after the rock is thrown? How long after the rock is thrown is it 370 feet from the ground? Okay, I'm just gonna use this, but we'll do it algebraically as well. So let's say I'm gonna plug in my nice new equation. You're gonna see that -16 a lot. Does anyone know why? Why does -16 keep popping up? Anyone know? Anyone know? The reason it keeps popping up is because it's gravity. We're on Earth. So -16 is the gravitational pull that pulls the thing back down to Earth. Oh my gosh, okay, we need to redo the scale here, okay, or just kind of zoom in differently. Okay, so think about it. I'm at the top of a building. The building, it should make sense, is 382 feet, because that's your y-intercept. So that's how high I am when I'm about to throw it, that's kind of my starting point. So I really don't even care about this side of the parabola. This left side doesn't really mean anything in terms of an application problem, because we're in the real world, we can't go to negative time. So we're starting here, kind of makes sense, you throw the rock, it's gonna go down and it's gonna hit the ground here. Okay, so it hits the ground after 4.763 seconds. Good stuff. But let's actually answer the question. How long after the rock is thrown is it 370 feet from the ground? So I'm gonna find 370. I don't know if I'm gonna be able to do this exactly. I don't know if it's gonna do that. Oh, look at that. Oh, there it is. See that point? 0.75, 370 means it's going to hit a height of 370 after 0.75 seconds. That's why technology is my friend. I don't even have to do any work. Now, technically, we can do that algebraically, so I'll just remind you of how to set up that equation, but now you know the answer if you're doing it. But once again, Desmos is a great program. I don't know if there's an app for it. You'd have to look. There might be. But I use it quite a bit. Sometimes I just get lazy and don't want to use my graphing calculator and I'm on a computer, so I just throw it up and it's easy to check stuff. Especially sometimes even if I'm solving a quadratic, I just look at the intercepts, little things like that. You'll see we're gonna do a lot of graphing next week, so something to look forward to. Okay, so I just wanna remind you for number 3, we looked at a graph and that's great, but next week when you're doing that little take home and we'll say, solve it, so you're not just kind of looking it up. So if it says how long after the rock is thrown is it's 370 feet from the ground, you're just gonna replace, in that case they use D instead of age, same thing, distance. They're gonna replace D with 370 and then solve. So once again, try it algebraically, you know the answer now with 0.75. And one thing I did wanna point out is that decimals are perfectly fine for word problems. So I know a lot of times we keep things in radical form. If I said something was 2 plus or minus root 3 over 7 seconds, you'd be like, I don't even know what that is. So for word, this is way brighter than one. For word problems, please use a decimal, so go for it. So as of right now, with kind of that intro and just doing a few problems, does anyone have any questions on our word problems? Okay. Let me turn on my beautiful new projector, which is so much brighter and more delightful. Yes, press this button. Oh, turn it off.